Hello everyone, welcome back to my channel. Today I would introduce you about the limit of a function. And I think it's a good idea to start with an example. Okay, so let's consider the function f(x) equal to x squared minus 4x plus 5. And then let's guess the graph. There we go. Just label it a little bit. 1, 2, x, and y, and 1, and 2. There we go. Okay, so let's get the graph. And this is basically what the function f(x) look like. Okay, so I have a questions for you that when you look at the graph, can you tell me which value of f(x) that is gonna get closer to as x approach to 1? As approach to 1, that means x get closer to 1 from both the right side and the left side. So just consider the right first. Let's trace the graph. And then when x approach to 1, it will pose here. There we go. And I see the point. And how about the left? Let's start with the left as well. And do you see the same thing with me? I feel like they are on pose or their own stop at that point, the blue one I just call it, where y equal to 2. Alright, so just write down our guess first. Our guess could be whether f(x) approach to 2. This means that f(x) get closer to 2 is when is x approach to 1. So how do we know if our guess is correct or not? The answer is making tables. So just choose some close number to estimate the result. Then make the table. And as I mentioned before, x approach to 1, that means x get closer to 1 from both sides, so we need to table. 1 for x less than 1, and then 1 for x greater than 1. And the better number you choose, the better estimation you get for the result. So let's choose the number wisely. I have some option for you and I would do right now. You can choose order, but just make sure it's very close to 1 and give you a good result. Let's start with 0 first, which is very close to 1 and the whole number. Then 0.5. The next one is 0.9. You might see that the number now is getting much closer to 1. That's what I want. There we go, 0.99 and then 0.999. For x greater than 1, you might choose kind of similar ways. So I will start with 2 with the whole number and very close to 1. And then 1.5. And the number could get much closer to 1. So 1.1 and then 1.01. And finally is 1.001. So this is how the table basically look like. And then for the f(x) volume, how we get the number or the answer for it. So basically you just plug the x value into the function f(x) and then solve for the numbers. I got the answer already, so I could write it now. You can pause the video and go back to check it later. So for x equal to 0, we got 5, and then 3.25, 2.21, 2.0201, and the last one we got 2.002001. And for x greater than 1, just do the same process. We got with x equal to 2, we got 1, and then 1.25, 1.81, and just do the whole until you complete the table. There we go. For the last one, we get 1.9998. So if you consider the last number or the closest number from each table, how do they tell us about where does the function f(x) abroad to? Is x abroad to 1? Or do you notice any special value which the choose number are getting closer to? So the answer is 2. Let me rewrite it a little bit. So both from the left and the right, the f(x) get closer to 2. Therefore, we have the quick conclusion here. Let me write it down. So, because the function f(x) would approach to 2 is it's shown on the graph, and also by confirming with our tables that f(x) get closer to 2 is x approach to 1. Therefore, we can say that the limit of the function f(x) is x approach to 1 could be equal to 2. Then we would have the overall conclusion of a limit. So the limit of a function could be denoted by limit of function f(x) is x approach to a would be equal to L if the function f(x) approach to L is x approach to a from both sides. Then let me give you 2 basic limits which you might see it again in the next topic. So let a is a real number and c be a constant. So we would have the first limit. It could be the limit of function x is x approach to a could be equal to a. This makes sense, right? Because the function now is the x itself. So as x approach to a, the limit of function x could be equal to a. Then we have the second limit. So the limit c is x approach to a would be equal to c. Because c is a constant, so it does not depend on the value of x. So whatever x is, the function itself would be the same, or the limit of the function c could be equal to c. And that is the general idea of a limit. And we will talk about one-side limit and two-side limit and some of their example in the next video. So see you there!